In this video, we look at the solubility rules for ionic compounds. We determine which ionic compounds are soluble in water and which are not. And this becomes important later on in trying to work out the products of chemical reactions in aqueous solutions, or trying to work out whether a reaction actually takes place at all. We saw in the previous video that ionic compounds that are soluble in water are called electrolytes, and that's because when they dissolve in water, they completely dissociate into their constituent ions, and those ions are able to carry electrical charge in the presence of an electric field, and they become mobile in that electric field in order to create an electrically conducting solution, hence the term electrolytes. We also saw that ionic compounds that are insoluble in water do not dissolve to produce freely mobile ions, and therefore do not produce electrically conducting solutions, and these compounds are called non-electrolytes. So it begs the question, how can we tell which ionic compounds are soluble or not, and what is solubility anyway? The solubility of a compound is the maximum amount of solute that can be dissolved in a given amount of solvent, and typically it's measured in grams per litre, although very often we do see grams per 100 mils, which is also referred to as percentage. So a 3.5% solution of sodium chloride would have 3.5 grams per 100 mils of sodium chloride solution. In order to be classed as soluble, a compound must be able to be dissolved in water at greater than 0.1 grams per 100 mils, or greater than 0.1% mass per volume. This table here shows a list of soluble compounds, and in effect tables like this we can refer to as our solubility rules. What we see here is a whole list of compounds that are soluble in water with no exceptions. So all group 1 metal salts, all lithium salts, potassium salts, sodium salts, etc. are all soluble in water, and there are no exceptions. All ammonium salts are soluble in water, no exceptions. Same with nitrate salts and acetate salts. All of those soluble in water with no exceptions. Most of the halide salts, the salts containing chlorides, bromides, iodides, most of these are soluble in water as well. There are 3 important exceptions, however. Silver, mercury and lead. So you can see there's silver chloride, mercury chloride, lead chloride, important exceptions. They are insoluble in water. They will not dissolve. Silver ions in the presence of chloride ions will actually form a solid precipitate. They will not dissolve in the presence of each other, and it's the same for the mercury and the chloride and the lead and the chloride. Most sulfate salts are also insoluble, again the exception being the big 3 there of mercury, silver and lead, and we've got 3 additional ones as well. You can see that calcium sulfate, strontium sulfate and barium sulfate are insoluble in water as well, and they are the heavier group 2 metal sulfates. So calcium, strontium, barium all being group 2 metals that lie below magnesium in the periodic table. This table here shows a list of insoluble compounds. Most carbonates, phosphates and sulfides are insoluble, but the exceptions being, we can't break the rules from the previous page. So group 1 metal carbonates and group 1 metal phosphates and group 1 metal sulfides, etc. are soluble in water, but all other carbonates, phosphates and sulfides are insoluble. The same goes for hydroxides. Most hydroxides are insoluble, the exceptions being the group 1 metal hydroxide, that's lithium hydroxide, sodium hydroxide, potassium hydroxide, etc. And the exception here again being the heavier group 2 metals, calcium, strontium and barium hydroxide. Now the hydroxide ion is an important ion. It's the source of the hydroxide ion, the base that we know is the hydroxide ion. And bases are important because they neutralize acids, and so all group 1 metal hydroxides, lithium, sodium, potassium hydroxide, etc., are good sources of the hydroxide ion in solution, and so too are calcium, strontium, and barium. They are good sources of hydroxide ions, those salts. Just remember, a salt that's considered insoluble does not dissolve in water very much. Its solubility would be less than 0.1 grams per 100 mils, or less than 0.1%.